So we're going to review some topics that you can expect to see on the Module 3 test. So question 1 says, consider the polynomial function f of x equals negative 3, x plus 2 squared, x minus 4, x plus 5 cubed. We want to know what the degree of the function is. Instead of expanding out the polynomial to find the degree, we can count the multiplicity of each of the factors. And if we look, our first exponent is 2, x minus 4 is 1, x to the 5 has multiplicity 3. So the total number we would have is 6. So the degree of our function is 6. Next, we want to determine the end behavior of our function. Well, based on the degree, I know it's even, and the end behavior is going to be the same for an even function, and the leading coefficient is negative, which means it's going to open down. So I know both of the ends of my graph are going to approach negative infinity. So my first statement, x approaches infinity. The function f of x is going to approach negative infinity. And my second statement is going to be for when x approaches negative infinity, our function is going to do the same thing. It is going to approach negative infinity. Next, we want to find the zeros of f of x. Well, our zeros come from our factors. With x plus 2 as a factor, I now have a 0 at negative 2, 0. With a factor of x minus 4, I know I have a 0 at 4, 0. And with x plus 5 as a factor, I know I have a 0 at negative 5, 0. And those are all my zeros. Now, negative 2, 0 has multiplicity 2, and negative 5, 0 has multiplicity 3. That's how I get 6 as the total number. Lastly, we're going to sketch a graph and label our intercepts. When we graph it in Desmos, our graph doesn't show up in the entire window that we have, but we can get a general idea of the shape, and it looks something along these lines. And we get our zeros at negative 5, 0, negative 2, 0, 4, 0, and our y-intercept is some positive number that is higher. Number 2, we want to determine a degree 3 polynomial with real coefficients which has zeros of 3 and 1 plus I. From the consequence of the fundamental theorem of algebra, we know the degree determines the number of complex zeros you have. And if I have a 0 of 3 and I have a complex 0 of 1 plus I know I have to have a second complex 0, and it has to be 1 minus I. It has to be my other 0. So my polynomial, f of x, is going to have, in factored form, is going to be x minus 3. And then my complex zeros will be x minus 1 plus I, and x minus 1 minus I. And to get our polynomial, we want to distribute this through. And I'm going to start with distributing the complex portion of the polynomial. we distribute x times x, we get x squared. Then we get minus x times 1 minus I minus x times 1 plus I, and then we get plus 1 plus I. So now that we've distributed our second set of parentheses, we now want to simplify. So we still have x minus 3 we have x squared. We're going to distribute the negative x in the parentheses. We get negative x plus ix. Then distributing our second negative x, we get negative x minus ix. And then we want to distribute our 1 minus I to the 1 plus I. And we end up with 1 plus I minus I minus I squared. We want to continue simplifying. Still have x minus 3. We end up with x squared. The plus ix and the minus ix cancel. The plus I and the minus I cancel. And then we have negative x minus x, which becomes minus 2x. And then we have plus 1, and then we have minus, and then we want to replace I squared. And I squared is equal to negative 1, so it becomes minus negative 1. Which then becomes x minus 3. And then x squared minus 2x. And then 1 minus a negative 1 comes 1 plus 1, which is plus 2. Last step is then going to be distribute the x minus 3 to the x squared minus 2x plus 2. So we get x cubed minus 2x squared plus 2x minus 3x squared plus 6x and then minus 6. So combining like terms, we end up with the polynomial of x cubed negative 2x squared minus 3x squared is negative 5x squared. 2x plus 6x gives us 8x. And then minus 6. And that would be our final answer. Number 3, given our function g of x equals x cubed minus 5x squared plus 2x plus 12, we want to first list all of the possible rational zeros of g of x. So that involves finding p and q and then doing p divided by q. So p is, remember, all of the factors of our constant, which is in this case 12. So our factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Q is all of the factors of our leading coefficient, which is 1. And the only factors of 1 are 1. So Q is plus or minus 1. Our possible rational zeros come from dividing P and Q. So we divide all of the factors of P by all of the factors of Q. And since the only factors of Q are 1, when I do the division, we end up with just the factors of what we listed for P. So we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now I want to find all of the zeros of g of x, and this includes the rational zeros and any complex zeros we may have. And when we graph the function in Desmos, we end up with 3 real zeros, and only one of them comes from our list of rational zeros, and that is going to be 3. So what we're going to do now is use synthetic division to divide g of x to end up with a quadratic, which we can then solve using the quadratic formula. So plugging in our 0, 3, our leading coefficients, or our coefficients, I should say, are 1, -5, 2, and 12. Bring down 1. 1 times 3 is 3. -5 plus 3 is -2. -2 times 3 is -6. 2 minus 6 is -4. -4 times 3 is -12. And we get 0. So we end up with the quadratic x squared minus 2x minus 4. And then we want to use the quadratic formula to find the rest of our zeros. So we get x equals -2 plus or minus the square root of -2 squared minus 4 times 1 times -4 all over 2 times 1, 2 plus or minus square root of 4 plus -4 times 1 is -4 times -4 is positive 16 all over 2. So we get 2 plus or minus the square root of 20 all over 2. And we do want to simplify the square root of 20. And we simplify the square root of 20, it becomes 4 times 5. The square root of 4 is 2, so we end up with 2 plus or minus 2. Underneath the square root, we still have 5 all over 2. And we do want to simplify. Anytime numbers outside the square root can simplify, we want to do that. 2, 2, and 2 all are divisible by 2. We end up with 1 plus or minus the square root of 5. So those are my last 2 zeros. So now we want to write our function as a product of its linear factors. So we're going to start with the rational 0. So with 3 being a rational 0, I know it gets written as a factor of x minus 3. Then we're going to write 1 plus square root 5 as a 0, which becomes x minus, then in parentheses, 1 plus square root 5. And then we have x minus, and then in parentheses, 1 minus the square root of 5. And the leading coefficient of our function g is 1, so I don't have to worry about writing a number in front of my function. So that is our function g of x in factored form. Question 4, we want to solve the equation x cubed minus x squared plus 12x minus 12 equals 0. So when we're talking about solving an equation, it means finding all zeros, real and irrational. So graphing our function in Desmos, we end up with one rational 0, and that is at the point 1, 0. So just like in our previous problem, we're going to divide through using the synthetic division to get a quadratic, which we can then finish solving using the quadratic formula. So putting in our 1, we have coefficients 1, negative 1, 12, negative 12. Then the 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. 12 plus 0 is 12. 12 times 1 is 12. And we end up with remainder of 0. So now we have the quadratic x squared plus 12 equals 0. So since I don't actually have an x term, instead of using the quadratic formula, we're going to use the square root property. So it says isolate the squared variable. That involves subtracting 12 from both sides. So we end up with x squared equals negative 12. Now that x squared is isolated, we're going to take the square root of both sides. We end up with x equals, always have plus or minus when we use the square root property. Now we have to simplify the square root of negative 12. Well, 12 is 4 times 3. Square root of 4 is 2. So I'm going to have a 2. The square root of a negative always involves I. So we have I. And then what's left underneath this square root is 3. So x equals plus or minus 2i radical 3. So all of my solutions for x, so x equals, when I solve the cubic, 1, 2i radical 3, and negative 2i radical 3. Number 5, what is the quotient of x to the 4th minus 8x squared plus x minus 8 divided by x plus 3? So to divide, we're going to use synthetic division. We're going to put the value that makes x plus 3 0 in our box, so that's going to be negative 3. Putting up our coefficients, we have 1x to the 4th. We do not have a cubic term, so we put a 0. Then negative 8x squared, 1x, negative 8. Bring down the 1. 1 times negative 3 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 9. Negative 8 plus 9 is 1. 1 times negative 3 is negative 3. 1 minus 3 is -2. -2 times -3 is 6, and -8 plus 6 is -2. So remember, the last number is always our remainder. So we write out our answer. Everything to the left of this are the coefficients of our terms, starting 1 degree less. So we have 1x cubed minus 3x squared plus x minus 2. And then to write a remainder, I keep the sign as my operation, so it's a -2, so I'm going to put minus, and then we put our number 2 over what we divided by, x plus 3. And this is our quotient. Last question, number 6. Is x plus 2 a factor of x cubed plus 3x squared plus 4x plus 4? Justify your answer. So we could use synthetic division and divide and see if we get a remainder of 0, or we can just use the remainder theorem. So the factor theorem states x plus 2 is a factor if and only if the remainder is 0. So we can use the remainder theorem with r equal to -2 to find the remainder. So we're going to evaluate it for -2. So -2 cubed plus 3 times -2 squared plus 4 times -2 plus 4. -2 cubed is going to be -8 plus 3 times -2 squared, which is +4. 4 times -2 is -8 plus 4. We end up with -8 plus 12, and then -8 plus 4 is -4. So -8 plus 12 is 4. 4 minus 4 is 0. So is x plus 2 a factor? The answer is yes. My justification is because the remainder is 0.